Welcome back. We're in Module 5.3, and we're going to talk about a practical application of why we need to have negative exponents in real life. And what we're going to talk about today is something called scientific notation. You've all may have heard of that before if you've taken any kind of science class, whether it's earth science or chemistry. Okay, think about some concepts. If you measure the distance from the Earth to the Sun, that distance is approximately 93 million miles away. If you were in a class and you were measuring the size of a dust particle, that's so small that you can't even see it with the naked eye. So that wouldn't be a very large number, that would be a very small number. And the size of a dust particle is approximately decimal point 0.00000000753 kilograms. Very small number. Both of those numbers have in common a fact. The fact is they contain a lot of digit zeros. And in science, we do not like to write numbers that contain a lot of placeholders of zeros. So there is a way to transform both of those numbers, whether it's a very large number with a lot of zeros as placeholders or a very small decimal with a lot of placeholders as zeros. We can transform, rewrite both of those numbers in something we call scientific notation. Okay, scientific notation is a way to write a number by excluding the zeros. Now, how do we change these numbers to scientific notation? Well, if you look, 93 million written in scientific notation is 9 3/10 times 10 to the 7th power. The size of the dust particle written in scientific notation is 7 53/100 times 10 to the negative 10th power. So what I want you to notice is, first of all, scientific notation is a notation. It's a way to write something. We all understand in this day and age texting. We all have a shorthand, a slang for texting. LOL, OMG, IDK. We all know those abbreviations. Well, that's what scientific notation is. It's an abbreviation, a way to write a number by taking out all the placeholders as zeros. When you write a number in scientific notation, you must have some key components. The first thing both of those numbers have in common is they have a decimal number that is bigger than 1, yet smaller than 10. 9 3/10 is bigger than 1, smaller than 10. 7 53/100 is bigger than 1, yet smaller than 10. So to write a number in scientific notation, the first part, the first component, is to have a decimal number between 1 and 10. The second component of scientific notation is to write times 10 to an exponent. Now you're saying, why times 10? Because, ladies and gentlemen, your whole number system is based on powers of 10. Think about our number system. We have ones place, tens place, hundreds place, thousands place, and etc. 1,000 is 10 times 10 times 10, which is 10 cubed. So 1,000 is a power of 10. 100 is 10 times 10, which is 10 squared, which is a power of 10. The tens place is 10 to the first, which is a power of 10. The ones place is 10 to the 0, because we've already discussed in the modules, 10 to the 0 is the number 1. So the ones place is a power of 10. All of our place values in our number systems are powers of 10. So that's when we write a number in scientific notation, it's going to say times 10 to some exponent. Now in 93 million, the exponent is a positive 7, because if you take the decimal point in 9 3/10 and you move that decimal point 7 positions to the right, you'll make 93 million. So when the decimal point travels to the right, you're making the number bigger in scientific notation. In our other number for the dust particle, 7 53/100 times 10 to the negative 10, because your exponent's negative, that's taking that decimal point in 7 53/100 and moving it to the left 10 positions. And that's what's going to happen. Anytime a number is written in scientific notation and your exponent's negative, it means the decimal point went back to the left and it made a decimal value. Therefore, our whole concept is here, is if you have a number that has a lot of zeros as placeholders, that number can be written in scientific notation. When you write a number in scientific notation, you must have two key components. You must start with a number between 1 and 10, bigger than 1, less than 10. And the second component, it's times 10 to some exponent. If the exponent's positive, the decimal point moves to the right, the number gets bigger. If that exponent's negative, the decimal point would move to the left, and that number would get smaller. That's why it would be a decimal value. In our next video, we're going to actually learn how to do this conversion. So I'll see you then.